Good morning, I am Dr. Rambabu. In this session, I am going to introduce the synchronous optical networks, the SONET. The synchronous optical network is a class of wide area network. The wide area networks can have the range of few kilometers to few thousands of kilometers. It can cover the entire country. The range of the wide area networks is very high, and the data rates supported by the fiber optic networks is very high. It is in the order of terabits per second these days. The fiber optic networks laid under the ground and also under the sea to connect the entire globe. We just revise the classification of networks by distance to understand the range of the wide area networks. The networks are basically classified by the distance, like personal area networks, local area networks, metropolitan area networks, wide area networks, and internet. The range of the personal area network is very less, that is around 10 meters. The communication can happen between the devices which are present in a room. The local area network, the range of the local area network is around 2 kilometers. So devices available or present in a campus or a room can be connected through local area network. The metropolitan area networks can cover the entire city. The range of the metropolitan area network is approximately 40 kilometers. Above the 40 kilometers range, any network that is having the connectivity of devices or computers is called the wide area network. The range of the wide area network is from covering entire city to entire country to entire globe. The wide area network can use a guided media or unguided media. The SONET is the synchronous optical networks is a part of the guided media of the wide area networks. In this session, we will see about the SONET introduction, optical network standards, architecture of the SONET, the layers in the SONET, and the device layer relationships in the SONET. The SONET is a wide area network as we have discussed. It is a synchronous network which uses synchronous EDM multiplexing. The SONET is used as a transport network for carrying data from variety of networks. Like it can get connected to PAN, a LAN, a MAN, or a number of wide area networks. The SONET uses high bandwidth fiber optic cables, so it is convenient, or it is a media which can transmit high data rate technologies like video conferencing and for carrying a large number of low rate technologies at the same time. For this reason, the fiber optic networks are having a lot of importance and gaining importance these days. If you see in this diagram, you can see how the world is connected through fiber optic networks. This is an undersea fiber optic network connectivity. In India, we have the National Optical Fiber Network, NOFN. It is introduced in the year 2011 to connect the India, especially in the Gram Panchayat levels. Around 2,50,000 Gram Panchayats have been connected with this NOFN. The fund provided for this NOFN is around 20,000 crores. The access to NOFN has been provided to all the service providers like telecom service providers, internet service providers, cable TV operators, and content providers. They can launch variety of programs and services in the rural areas like e-health, e-education, and e-governance. This is the fiber optic network in India, which is covering entire India. Now we will see the optical network standards. There are basically two standards defined for synchronous optical networks. One is the SONET, that is Synchronous Optical Network, developed by American National Standards Institute, that is NC. The second one is SDH, Synchronous Digital Hierarchy. It is developed by ITU-T. To understand the architecture of the SONET, we need to understand three components. They are signals, SONET devices, and SONET connections. SONET signals, there are three different types of SONET signals, that is STS, OC, and STM. SONET defines hierarchy of electrical signaling levels called synchronous transport signals, that is STS. Each STS level, STS1 to STS192, supports certain data rate specified in megabits per second. The corresponding optical signals are called optical carriers, OC. The ITU-T standard, which has defined SDH, it has defined another term, that is synchronous transport module. The STM level, STM1, is having data rates of 155.520 megabits per second. In this table, we can see the STS signals, optical carriers, and corresponding data rates, and corresponding STM. We can see here STS1 to STS192, and STS1 corresponds to OC1. The data rate is 51.840 megabits per second, and STS3 is having OC3. The data rate is 155.520, and it is corresponding to SDH, STM. Here in this diagram, you can see a simple SONET network. The T here are the terminals, which can be connected to STS multiplexer. Then this multiplexer will convert the electrical signals from the terminals into optical signals, and these are the regenerators, and this is ADM, and this is STS demultiplexer, and these are the various terminals. Here the regenerator will regenerate the electrical signals, reconvert optical signals into electrical signals, and regenerate the electrical signals, and again reconvert the electrical signals into optical signals, and forward to the next regenerator. This EDM add-drop multiplexer can add the different signals, and also it can give the path away to different connections. The STS demultiplexer does the reverse process. It will convert the optical signals into electrical signals and give it to the terminals. Here in this we can see the communication between one device to another device, adjacent devices, are called the sections, and between the STS multiplexer to ADM, or from the ADM to STS demultiplexer, it is called the line, and from STS multiplexer to demultiplexer, from source to destination, it is called as a path. Now we will see more details about these SONET devices. The STS transmission relies on four basic devices: the STS multiplexers, demultiplexers, regenerators, add-drop multiplexers, and terminals that we have seen in the previous diagram. The STS multiplexer or demultiplexers mark the beginning point and end point of the SONET link. STS multiplexer is at the beginning and demultiplexer is there at the end. They provide interface between electrical tributary network and the optical networks. The synchronous network, SONET, which can carry different, it can integrate to different types of networks like LAN, PAN, and WAN. That's what we have seen in the in this session. So they will convert the tributary network signals into the optical signals. In STS multiplexer, multiplexes the signals from multiple electrical sources and creates corresponding optical signal. And STS demultiplexer demultiplexes an optical OC signal into corresponding electrical signals. The regenerator extends the length of the links. When the distance between two segments is more than 40 kilometers in the fiber optic networks, we need to have regenerators. A regenerator is a repeater that takes a received optical OCN signal, demodulates it into corresponding electrical signals, STSN, regenerates the electrical signal, and finally modulates the electrical signal into its corresponding OCN signal. A SONET regenerator also replaces some of the existing overhead information, that is header information, with the new information. The add-up multiplexers allow the insertion and extraction of the signals from the optical cable network. An add-up multiplexer can add STSs coming from different sources into a given path, or it can remove a desired signal from the path and redirect without the demultiplexing the entire signal. To summarize, in this session we have seen what is a wide area network, what is a SONET, the different standards of the SONET, how the SONET is connecting the entire world, and the SONET in the India, and we also seen the signals of the SONET and simple SONET network and functions of various devices in the SONET network. Thank you very much.